All right, boys and girls, this is the lesson that we learned for today. It's dealing with similar triangles and this line right here. Okay, so this line is called the side splitter. And if it's and what does it do? Well, it creates two similar triangles. You see the inner triangle and then the outer triangle. So the most important thing that you have to recognize with this is that whenever you have any problems, any questions dealing with a triangle that's split like this, you want to draw two similar triangles, right? The inside, which is the ADE triangle, and then the outside, which is then going to be the ABC triangle. And with anything that is similar in nature, you always want to set up a proportion to be able to solve for your work, okay? That's the main idea. So draw a picture, set up a proportion, okay? Then there's a very special type of side splitter. Again, it's a side splitter. The other type is called this thing right here. Now, I'm just being precise in drawing it so that I can show you guys. This is actually called a mid-segment side splitter, okay? Why is it called the mid-segment? Well, the two endpoints, this and this, are actually the midpoints of this and this, okay? So what's the special feature? Let's call this A, C, E, and then B and D. Because this is the midpoint, this side is always going to be equal to this side, and CD is always going to be equal to DE, okay? So, for example, if I told you that AB is 5, you already know BC is going to be 5. And if it tell you that CD is 6, then you know that DE is going to be 6 as well. Now, that's that with the mid-segment line. There's something else. There's a special relationship that you need to know about this and this as well, okay? This is half of this size, or AE is twice the size of BD. So if I tell you that AE is 14, you automatically know, based on the fact that this is a mid-segment, that this has to be 7, okay? It's one of those basic relationships that you have to know, okay? So that's the summary. Now let's take a look at a couple of examples of how to break down these triangles to set up the proportion. Now we're not going to fully solve for it. We're just going to label and then show you guys how to think about solving for it, okay? Setting it up at least. All right, so we have here A, D, E, B, C, and let's take a look at this. AD is 6, right? AE is x plus 5. BD is x, and then EC is CE is 4, okay? So again, whenever you're dealing with similar triangles, you want to split them off of this line, right? So here you have the smaller piece, and here you have the larger piece, okay? And then you use the same labels that they give you. AD over here is going to be 6. AE is x plus 5, okay? Now AB from here to here is actually the combination of this and this. So it's x plus 6, right? This is x plus 6. And then AC is x plus 5 plus 4. So that's going to be x plus 5, and 5 plus 4 is 9. Okay, and that's it. Now that you have all the correct, all the correct measurements, then you could set up a proportion any way you want, but 6 over x plus 5 is equal to x plus 6 over x plus 9. And once you have a proportion, you just cross multiply and solve for x, and that's how you get to the answer, okay?